Can I? Why won't that move over for me? Oh, there. Perfect. Before I do that, does anybody have any question on what I was doing there, using no calculus at all? Just did area of those two triangles. Did anybody need help with that? Okay, let's do it the algebra calculus way here. I would still maybe use that picture, or you could kind of do this in your head. I would say, since I know this is going to touch the x-axis at 1, because it's an x minus 1, if I plug numbers into this, between 0 and 1, it's going to be negative in there. In other words, I'm going to need that absolute value sign. I'm going to need it. So in order to remove it, I'm going to have to put a negative sign out front. Like that. And this is from 0 to 1. From 1 to 4, if I plug those numbers in here, I don't need the absolute value signs at all. It's going to be a positive number anyway. So I can just remove them. There. And that's the hard part. From there on, you just integrate this normally. Okay, shall I go ahead and integrate? Okay. I'll have negative half x squared. And I'm going to take my negative through, so plus x. And this will be 0 to 1. And then I'll have half x squared minus x. 1 to, whoops, I'm sorry, 1 to 4, not 1 to 2. Should be a 4. Okay, so far? Okay. Here's plugging the 1 in. Plus 1. This will all be 0. Plus 1/2 times 4 squared minus 4 minus, here are the 1s. Okay, so over here now I have negative half plus 1 plus half times 16. Let's just make that 16 halves then. Minus 4 minus half plus 1. Let's see, this will be a half and 16 halves minus 4 plus a half. So it looks like 1 and 8 minus 4. Any questions? Okay, funky one's coming up, right? Uh-oh, now I don't know how to get my pages back. Anybody know? It's not that. Right there. Oh, that was it. Okay, 27. This one was kind of a little weirdo. This one had odd and even in it. I don't know if you noticed that or if you picked up on that, but it did. It was all about odd and evens. Come on. Okay, so you had a bunch of givens up here. Let's just look at this very first one. The kind of clue to me that I might be dealing with odd and evens was this. Right, the -2 to 2 part. Was f odd or even? Even, right here. This is what told you that f was even, which is why I immediately went and doubled the right-hand side, which was lucky for me because I have the right-hand side right here. Anybody have a question on the A part? No. Okay. B part was tougher because B part has this absolute value. But we're basically going to do exactly what we just did and say, Okay, is what's in here positive or is it negative? In other words, do I need those absolute value signs or do I not? Well, here's how I tell. This is telling me that the entire F curve is below the x-axis. The entire F curve is negative. So, there are negative numbers in here. So in order to remove my absolute value sign, I need this negative. Okay, and you can pull it out front here if you want or not, it doesn't matter. And then I did the same thing, double the right. So that's how I got the same answer as I had here, except the negated version. Anybody confused how I got rid of this now? No? Okay. Come on down to C. Did you realize that G was odd? So there's nothing to do there? Here's the G odd thing right here. Alright, so let me stop for a second and just make sure you don't want anything on A, B, or C. D. For D, I had to break this apart. This one's just another double the right here. What's going on with this? Yeah, look at this. Right? All I did is I know that f of negative x is equal to f of x, so I can just plug f of x in there. And then it's another double the right. Question? If it's even, you double the right. This is the even test right up here. So I knew by looking at this that f was even. I knew by looking at this that G is odd. The odd ones are just 0. The even ones are double the right. Anybody want me to do more work on the D part? I think E was just not really having to do with odd or even, right? Anybody need help on E? Okay, 28, here's a little odd and even business again. Do we want to talk about 28? Okay, 30. These are the drop-it-ins. I know they're drop-it-ins because I'm trying to take the derivative of an integral. This one, drop in the x, multiply by the derivative of x, which is just 1, so there's really no multiplying at all. Over here you get a little multiplying by the derivative, because this is an x squared, not just an x. Anything on 30A, 30B? 30C I don't really think you're ever going to see, but I threw it in anyway. Here's a case where you have variable top and bottom. Once you see the answer, you'll say, oh yeah, okay. I dropped it in on the top, multiplied by the derivative of x cubed, minus, doing the fundamental theorem of calculus here, drop it in on the bottom. So drop it in on the top, multiplied by the derivative, minus, drop it in on the bottom, multiplied by the derivative, which is just 1. So that's just a little fundamental theorem of calculus there. I wouldn't worry too much about C. I don't think you're ever going to see it. And then I think 31 is the end, isn't it? 31 is writing these guys as integrals. How do you know when it's an integration?
How do you know the limits?
Oh, the limits of integration. Right here, this 1 is telling you that it starts at 1. It's 1 plus the endpoint. Okay, so this 1 is telling you it starts at 1. This 2 up here, remember, is the span, because you have to do b minus a over n. Right? So if it starts at 1, and I have to end up on top here somehow with a 2, right? That b would have to be a 3. Does that make sense? And up here, the 4, there's no like 1 plus or negative 1 plus or 3 plus, so I know it must start at 0 and the span must be 4. Any other questions? Okay, let's go over your integrals quiz. And then I'll tell you exactly what's on the test. Integrals quiz was a long time ago, isn't it? Stop recording now.